Alright, so we're back to review the homework. Just make sure you're doing that out of the textbook. That's numbers 1, 3, 5, 7, 9, 11, and 13, 15, and 17. So that's about 1, 2, 3, 4, 5, 6, 7, 8, 9 problems total from your textbook. We're going to review some of the checkpoints before finishing off 11.2. So here they're asking us to simplify the expression. Assume that all variables are positive. So I'm going to give you a little bit of a hint here. For all of these, they all have the same base. So we're going to apply some of the rules that we learned. So when we're multiplying variables that are alike, we can actually add their exponents. And if we're dividing variables that are alike, we can subtract those exponents. So for here we could write this as x, a fraction, two fractions being added together. And then since we're dividing by one of the variables, we can also subtract that exponent. Now as you can see here, if I plug in all of my variables, they won't be alike. In fact, here's an example of how do I solve something like this when all the variables are not the same. So let's say if I had 1/4 plus 2/4, or I'll make that 2/8 minus, I don't know, 1/8. As you can see, 4, 8, and 8 are not the same. And no, I'm not doing this problem for you, but here's just an example of how you would deal with unlike denominators. So here, 4 and 8, I want to find out what the common denominator would be. 4, 8, 8, 16. It looks like 8's going to be the common denominator. And as you can see, for two of the fractions, nothing's really going to change. But for that first fraction, I will have to multiply both numerator and denominator to change that 4 and 2 and 8. So that would be about 2 times 4 is 8, 2 times 1 is 2. So if I add and then subtract all of my numerators, that should be 2 plus 2 is 4, take away 1 would be 3. And that would be my, if this was my fractional exponents, this would be my answer. Of course it's not, because it's not the same, but here's an example just so you can kind of go through that. For number 10, what I would do is simplify the expression by writing it using rational exponents. So that's the first thing I would do, is go ahead and write each part using rational exponents instead of radical form. Alright, now y to the 1, I just wrote that because there's only one exponent there. But take some time and work that out and simplify that even further. So if you do have variables that are alike, remember we can add exponents of like variables. So something like x 1/2 times x 1/3, we could add those together. And if we're dividing like variables, we can subtract. Right, and what that would look like here, just like you see here, if it's multiplying, we can add the exponents. If we were dividing, it would look something like that. So just make sure to apply that for number 10 and work that out. For number 16, which is the last one of our checkpoint, that would be, notice that for here we have a 5th root and a 5th root, which is kind of nice. So we can actually write this under one big radical 5th root, our first fraction, which is right here, times our second fraction and kind of simplify that out. In fact, if I multiply 125 times 25, I'll probably get a very large number. So I'll let you calculate that out. Times v on the numerator side, w to the 6th power on the denominator side to the 5th root. And see if you can actually take the 5th root of that number. See if that works out. I will give you a spoiler, it will. And we can actually write our variables under 1/5 root. So I'll let you work that out. If you do have any questions, come back on Wednesday and we'll go over any of the checkpoints or homework that you had questions on.